Okay, here's a problem I picked from pretty recent calculus. AP calculus test. It's from 2013, which is last year, and it's problem 5, which means might be a little bit difficult. Okay, so let's dig into it. Problem A. Let's read the problem first. Consider the differential equation dy over dx equals y squared 2x plus 2. Let y be a particular, and we know the initial condition f0 equals -1. Okay, the problem A asks us to find the limit as x goes to 0. fx plus 1 over sine x. Show the work that leads to the answer. Okay, let's try. So fx plus 1 at x equals 0. We know that when x equals 0, fx equals -1. So limit as x goes to 0, we have -1 plus 1 over sine 0 is 0. So we basically have 0 over 0, which means we can apply the L'Hopital's rule. So let's review a little bit for L'Hopital's rule. If the limit as x2 goes to 0, it's 0 over 0, then f prime, that equals f prime of x over g prime of x. So limit as x goes to 0, f prime x, the derivative of 1 is just 0. For the derivative of sine x is cosine x. So let's plug in 0 to that formula to get f prime x. So we have 2 in this case, and cosine 0 equals 1. So the limit is just 2. So problem B asks us to use Euler's method starting at x equals 0 with 2 steps of the equal size to approximate f a half. So with 2 equal size steps, which means delta x equals a quarter. So let's make a table. X, y, and delta y equals f prime fy. Don't forget to multiply by delta x. So, and we need 2 steps. For the first step's 0, and we know from the question y equals -1. So delta y equals f prime y, which we did in part A, equals 2, and then multiply by delta x, which is a quarter, and it's a half. So then in this second step, x equals a quarter, and y in this case should be these two add together, which is -1/2. So -1/2, same stuff, we're plugging -1/2 to the dy dx, and then multiply by a quarter. So we know delta y at x equals a quarter is 5 over 32. So we're asking for f a half, which should be the previous y value plus delta y. So y plus delta y. It's in this case -1/2 plus 5 over 32, which is -11 over 32. So that's for part B. Let's move on for part C. The part C finally asks for a differential equation with the initial condition f0 equals -1. So we first need to separate the y value and x value each to one side of the equation. So you divide y squared and multiply by the x. Then we write in a simplified way. Next thing we're going to do is to put integral on both sides of the equation. And it's just simple integration. It's negative 1 in the left side, and x squared plus 2x, and don't forget to put plus c. Then, since there's no log involved in this problem, we're just gonna solve c right here. So plug in 0, negative 1. So we got negative 1 to negative 1, 0, 0 plus c. So c equals 1. And then we just simplify it a little bit, because negative plus 2x plus 1. And we put the reciprocal on the left side, x squared plus 2x plus 1. And we got the answer. And the domain is pretty obvious in this case. Just x minus x is greater than minus 1. Okay, that's the whole problem.